light energy, and we have discussed with the term light, what is light, why light is regarded as a form of energy, and also the spherical mirrors. So these things we have discussed in the last class. Now today I'll explain you about some terms related with spherical mirrors. Now let us recapitulate what we have discussed, what I have explained in the previous class about the spherical mirror. Now the spherical mirror, what are the mirror are normally plane. The mirror can be curved, and the mirror whose reflecting surface is curved, we call it as a spherical mirror or the curved mirror. And spherical mirror is a part of the curved mirror. So now this spherical mirror is made up of a hollow glass sphere. So it is a part of a sphere. This spherical mirror is a part of a hollow glass sphere in which one curved surface is polished in silver and the other side has got reflecting surface. So in a spherical mirror, both the side doesn't have reflecting surface, only one side will be reflecting surface. The reflecting surface can be either the inner, the curved part, the curved surface, or the outer bulged surface. So we have discussed that, and also the two different types of spherical mirrors, concave mirror and convex mirror. So in a concave mirror, when we talk about this concave mirror, the reflection takes place from the inner curved part, that is from the inner part, okay, from inner surface, and the outer bulged part is polished in silver. So therefore, in a concave mirror, the reflection takes place from the inner side. Whereas in a convex mirror, the reflection takes place from the outer side, and the inner side, the inner curved side is polished in silver. So this is the difference, okay, in concave and convex mirror. Now let us come to the terms related with the related in spherical mirror. So first of all, we will come to the point pole of the mirror. Pole, P-O-L-E, pole. Now follow this diagram. Okay, so I have done 1, 2, 3, 4 diagrams I have drawn. So you follow the diagram, and also please refer your book page number 61, page number 61 to follow it. So the first one, let us come to the pole of the mirror. Now pole is, now this is the pole. Now when I draw the mirror, okay, like this, and this is the sphere, the entire portion is the sphere, and when I divide the sphere into two parts, so it becomes one side, one face, and another face like this. Okay, so these are the two faces which I already explained before. So when I divide the sphere into two parts, so it becomes like this. So one side, it has got a curved surface, one has got a curved surface here on both the side, and the reflection takes place from the two different surfaces. If the inner side is polished, then reflection takes place from the outer side. If the outer side is polished, reflection takes place from the inner side. So that is why the difference of spherical. So that is why it has been given that there are two different types of spherical mirrors depending on the reflecting surface. Now this is the sphere here. Now in this sphere, so this side. Now let us follow this right hand side. Okay. So right hand side, this curved surface, this curved part on the outer side is polished in silver. Okay, and the reflection takes place from the inner side. So that means this is a concave mirror. First, let us consider a concave mirror. So, and another one is the convex mirror. So, convex mirror means on the left hand side, I have made the inner side as a polished surface, and the reflection takes place from the outer side. So now pole. First of all is the pole. The pole means the geometric center. Geometric center means the midpoint. The center of the spherical mirror is called the pole of the mirror. So when we define pole, the geometric center of the mirror is called the pole of the mirror, which is denoted as P. So always when you draw the mirror, either the concave or the convex mirror, always at the center of this mirror, always at the center of the mirror, both the concave and the convex mirror, this center of the mirror is considered as the pole of the mirror. So therefore, when we define pole, it is the geometric center of a spherical mirror. So the first point is the pole. Second one comes the center of curvature. We call it as a center of curvature. Center of curvature means the geometric center of a spherical sphere, not a mirror. The geometric center of a sphere in which the mirror is a part. Suppose if I will draw a circle, okay, and how you draw a circle? You keep the needle of the compass and the mirror, and you draw a circle. With the help of a compass, you draw a circle. And that point we call it as a center of the circle. But here it is not a center of the circle, but we call it as a center of a sphere. Okay, so this C is the center of the sphere. It is not on the mirror. Look at it. It is not on the mirror. It is at the sphere end. So therefore we can say that C is the center of curvature, and this center of curvature is the center of a sphere in which the spherical mirror is a part. So therefore center of curvature will be here at this. That means it is the center of a sphere in which the spherical mirror is a part. That is the center of curvature. Then other point comes principal axis. A straight line drawn, a straight line passing from the pole and the center of curvature is called the principal axis. Principal axis is a straight line which passes from the pole and the center of curvature. If I draw a straight line, now this straight line here you can see this straight line is a principal axis. So principal axis is a straight line passing from the pole and the center of curvature. So therefore here PX is a principal axis. P is the pole of the mirror, C is the center of curvature, PX is the principal axis. Okay, and the another point is here, that is the aperture. Now the next point is the aperture. Now principal axis, center of curvature, then principal axis. Okay, now we will come to the aperture. Aperture means the area of the mirror, the area of the reflecting surface of the mirror. The area of the reflecting surface of the mirror. So that means M1 and M2 is the aperture. And aperture also signifies the area, how much area of a spherical mirror has got a reflecting surface. So more the curve, so more bigger the curve you can draw it, more the larger will be the reflecting surface. So the aperture denotes the area of the reflecting surface. So M1 and M2 is the aperture. Okay, and there are the two apertures. One is the linear aperture. The first one will come to the linear aperture. Now the linear aperture is the straight line, this straight line. The straight line which passes from the reflecting surface of the spherical mirror. The straight line which passes from the reflecting surface of the spherical mirror. So this is the linear aperture. So that means from M1 and M2, this side, this reflecting surface is the aperture, and the straight line which passes from the point M1 and M2, this straight line is the linear aperture, and other one is the angular aperture. Angular aperture means now the angle made, now this one M1C M2 is the angular aperture. That is the angle made by the aperture of the mirror M1 and M2 with the center of curvature. Okay, the angle made by this mirror M1 and M2 by this point region M1 and M2 with the center of curvature, that is the angular aperture. So M1C M2 is the angular aperture. M1 and M2. Okay, this one M1 and M2. This point is the linear aperture. Okay, and therefore when we consider this aperture itself is the M1P M2. Now this point is the aperture. Now the next one is the focus. Now we call it as a focus or the focal point or the principal focus. Three things we call it: focus, principal focus, or the focal point. Now this focus is a point on, we will just refer this diagram here. Focus is a point on the principal axis. It is a point on this the principal axis. Okay, so the line drawn from the pole to the center of curvature. This line is the principal axis, and on the principal axis there is a point. Okay, focus is a point on the principal axis in which the refracted ray, they will meet or they will appear to meet. It is a point on the principal axis in which the rays of light after reflection, they will meet at that point, or they will appear to meet at that point. They are known as the focus. So there are two focus in case of concave and convex mirror. So first of all, let us come to the concave mirror. So in a concave mirror, let us consider a beam of light parallel to the principal axis. These are the beam of light. Okay, beam of light. Now, what are the beam of light is? If a number of rays, if I draw only one line, only this one I will draw. So this we call it as a ray of light. Now, when there are number of rays, if I make more than one, I will make. Suppose if I made two rays, now we call it as a beam of light. Number of rays together they are known as the beam of light. So I have drawn a ray, that is a ray of light I have drawn here. So which we call it as a beam of light, which is parallel to the principal axis. Okay, a beam of light which are parallel to the principal axis after reflection. So since this is a concave mirror, because the reflection, you know that in a concave mirror, reflection takes place from the inner side. Okay, so and always you can see the center of curvature will be on this side, on the left hand side. Pole is here, center of curvature is here. Okay, and when I draw the ray of light which are parallel to the principal axis after reflection, this ray of light will meet at a point. All the reflected rays of light will meet at a point, and this point is called the focus or the principal focus of a concave mirror. Okay, so in a concave mirror, the reflected ray will they will meet or they will intersect, and therefore concave mirror is known as the converging mirror. Concave mirror is known as the converging mirror. Converging means to converge, to come together, to join. Okay, so therefore, now this act is a focus or a principal focus or focal point of a concave mirror. So this, when we define focus, focus is a point on the principal axis in which the rays of light after reflection they meet in case of a concave mirror. So now, and the next point is there, and the distance between the pole and the focus. The distance between the pole and the focus is known as the focal length. Okay, the next point is there, that is the focal length. The distance between the pole and the focus is known as the focal point. And the focal point is always half of radius of curvature. And see, from the next point is the, I forgot to tell you that about the radius of curvature. Okay, now the radius of curvature is the radius of a sphere. Okay, the radius of a spherical mirror. So that is from CP. This denotes the radius of curvature. C is the center of curvature. CP is the radius of curvature. Okay, P is the pole. I forgot to tell you that point. That is the radius of curvature. Radius of curvature means the radius of a spherical mirror. Suppose if I draw a circle, okay, and this is the center of the circle, and if I draw, and let us consider as center of the circle as O, and from O if I draw here A, so OA is the radius of the circle. Then again if I draw here, OB is the radius of the circle. So but AOD or DOA will become as the diameter of the circle. Okay, so likewise, A is, in case of a spherical mirror, A means it is a pole, O is this center of curvature, and AO is the radius of curvature. So radius of curvature is the radius of a spherical mirror. The radius of a spherical mirror, we call it as a radius of curvature. Then AOB, this is known as the diameter of the circle, but in case of a spherical mirror, BC axis will become as a principal axis. Okay, so now this diameter, in case of the circle, if I draw the circle, that is a diameter. AOB will become as a diameter, but in case of a spherical mirror, PCX will become as a principal axis. So that is the difference. You just think over it. You just imagine that if you have drawn a circle, to draw a circle, you will keep the pointer for compass at the center, and you draw a circle. That point will become the center of the circle. Okay, which we, but in case of a spherical mirror, we call it as a center of curvature. and from the center of the circle, when you draw one side towards the circumference of the circle, that will become as a radius, and again when you draw another line towards the another part of the circumference, that also become radius, and when you consider the entire length AOB, that becomes as the diameter of the circle. Okay, like in mathematics which we have done. Likewise, like that. But here there is a difference. Okay, we cannot call as a center of the circle, diameter of the circle. Instead of diameter, we call it as a principal axis here. So principal axis is the line joining the pole and the center of curvature. If I draw a straight line which joins pole and the center of curvature, so that line is the principal axis, and the line PC will become as a radius of curvature. So radius of curvature is the radius of a spherical mirror, or the radius of the sphere. Okay, so now in case of a concave mirror here, we have discussed about the term focus. So focus is a point on the principal axis in which the reflected rays of light, they will actually meet or they will appear to meet. In case of a concave mirror, this is a concave mirror. Okay, now why it is a concave mirror? You know that because reflection is taking place from the inner curved surface. Outer side, the outer bulge part is polished in silver. So reflection is taking place from inner side. So I have drawn a beam of light which are parallel to the principal axis. And these rays of light, when it strike the mirror here, then reflection takes place, and all the reflected rays, they will meet at a point, and that point is the focus. Okay, in case of a concave mirror. Now from this point, let us come to the focal length. Now focal length is the distance between the principal pole and the focus of a mirror. So this distance, the distance between the pole and the focus of a mirror, this is known as the focal length. Okay, this is known as the focal length. And focal length is written as small letter f. Focal length is always half of radius of curvature. So that means r by 2. Radius of curvature is taken as capital R. And what is the radius of curvature here? PC. This is the radius of curvature. Okay, the CP. Okay, that means CP or PC is the radius of curvature. Like PC or CP is the radius of curvature, and radius of curvature is always more than the focal length. Focal length is half of the radius of curvature. If the radius of curvature is 4 cm, then focal length will be 2 cm. So you have to remember the relation here. Focal length, small letter f is written as r by 2. So r is the radius of curvature, and small letter f is the focal length. So f equals to r by 2, and when you cross multiply here, radius of curvature equals to twice the focal length, 2 times the focal length. So this relation is very important when you do the numericals. This you have to remember. Focal length is half of the radius of curvature, and radius of curvature is twice the focal length. So if the radius of curvature is 4 cm, focal length will be 2 cm. Okay, focal length will be half. If the focal length is 2 cm, radius of curvature will be 4 cm. So there is a difference here. So this is about the focus in case of a concave mirror. And concave mirror is known as a converging mirror. Remember that. Concave mirror is known as a converging mirror because the reflected rays of light, all they will meet at a point. They will all converge at a point. And the next point, in case of a convex mirror, now this is a convex mirror. So in a convex mirror, the reflection takes place on the outer side, and the inner ground surface is polished in silver. So therefore, now this line I have drawn here. Okay, now this point is now here it is a pole. Okay, so in case of this, now this pole is here. Okay, and other side what I have drawn, this is the center of curvature here. This is the center of curvature. Okay, and this is the pole, and the beam of light or the rays of light is parallel to the principal axis. After reflection, they will diverge. That means they will not reflect. They will reflect. That means the reflected ray they will get scattered. They will get diverged. You can see this ray here. They are diverging upward and they are diverging downwards. Now this reflected ray are produced backward. They are produced backward. The reflected ray are not actually intersecting here. The reflected ray are produced backward, and they appear to meet at focus. And it seems that the rays of light are coming from the focus. Okay, so therefore this F is a focus or a focal point or the principal focus of a convex mirror. So when you define focus of a convex mirror, then it is a point on the principal axis in which the reflected ray appear to diverge. The reflected ray appear to diverge, and it seems that the rays of light are coming from the focus. So that is the focus or the principal focus in case of a convex mirror. Okay, and in convex mirror also you can find the focal length also as well as the radius of curvature. So these are the technical terms. These are the terms which are related with the spherical mirror. So when you draw the ray diagram, there are some questions related with the ray diagram. Okay, so in that case you have to remember which one is the pole, which one is the focus, which one is the center of curvature, radius of curvature. These things you should be able to know it. Now the next one will come to the images. Okay, now the two types of images are there: real image and virtual image. Now always you know that either it is a plane mirror or the curved mirror, they always form image. And image are formed when the light gets reflected. When the reflection takes place, then the images are formed. So in a plane mirror, also the reflection takes place, as well as in a curved mirror, also the reflection of light takes place. And when the reflection of light takes place, then the images are formed. So the two types of images are here, and two mirrors are here. That is a concave and convex mirror, and both the concave and convex mirror will form the real and virtual image. So in case of a real image, when we define real image, the images are formed by the actual intersection of the reflected rays are known as the real image. So real images are formed by the actual intersection of reflected rays. Virtual images are formed without the intersection of the reflected ray, but this reflected ray, when they are produced backward, they will appear to meet. So just now I discussed about the two diagrams of a concave and a convex mirror, that means the expansion of a focus. In case of a convex mirror, what has happened here is a ray of light which is parallel to the principal axis. After reflection, that reflected rays of light, all they will meet at one point. That point is the focus. So likewise, in a real image also, all the reflected rays, they will meet at a point. When the reflected rays of light, they will meet at a point, and in that point, the images are formed, and that image is a real image. But in case of a convex mirror, a beam of light or the rays of light parallel to the principal axis, after reflection, they will diverge, they get scattered in a different direction. But these reflected rays are produced backward, and they will appear to meet. This reflected ray will appear to meet when the same reflected ray are produced backward. They are not actually intersecting, but they will intersect when the reflected rays are produced backward. Then in that point, the image are formed. That image is the virtual image. So when we talk about the virtual image, the images are formed without the actual intersection of the reflected rays, but when the reflected ray are produced backward, these rays will appear to meet and forms image, and that image is the virtual image. And next point is there, the real image can be cast on the screen. That means we can able to see on the screen. On a white screen, if you stand in front of the white screen, you won't be able to see your own image. But from the projector, the film which has been projected on the screen with the help of the projector, okay, the different images which you see on the screen, that is the real image, because the real images are formed by the actual intersection of the reflected rays. And virtual image cannot be cast on the screen. And the real images are always inverted. Real images are always inverted, means upside down. Okay, upside down. Virtual images are always erect. Virtual images are always erect. And the real images are formed on the same side of the object. Whichever side you keep the object, after reflection, the same side, on the same side of the image, on the same side of the object, the image will be formed. In case of a real image. Okay, because from the object, the rays of the incident ray of light will go to the mirror, they fall to the mirror, and reflection takes place. Okay, when the reflected ray will come and converge at one particular point, on that point the image is formed, and therefore the image formed by the real image which has been formed, and real image always form the image on the same side of the object. And in a virtual image will form the image behind the mirror, not on the same side but on the opposite side. Virtual image will form on the behind the mirror, because in front of the mirror, when the rays of light will go, the ray of light gets scattered, and this scattering, the rays of light which has been scattered or which has been diverged, they are producing backward. That means they will produce that ray backward. So therefore, on the behind the mirror or at the back side, you will see the image. So therefore, these are the difference of the real and the virtual image. Now let us come to the ray diagram. So to draw the ray diagram, the three things you have to remember. And always you know that the plane mirror also forms the image. Okay, and the image can be inverted. Okay, it can be real image, inverted image, same size of the object, smaller than object. So that means the different characteristics are there. Similarly, the image formed by the spherical mirror also has the different characteristics. So depending upon the object, depending upon the focal length, okay, depending upon the focal length. Focal length means the distance from the pole and the focus. Okay, so that one is known as the focal length. So depending upon the focal length, okay, and also the object, where we keep the object, okay, the size of the object. So depending upon that, the image formed by spherical mirror may be different. So the three things you have to remember when you draw the ray diagram. Number one point is, suppose in case of a mirror, let us consider first as a concave mirror. So in a concave mirror, okay, this is the pole, this is the focus, and the center of curvature. A ray of light passing through the center of curvature. When the ray of light passes to the center of curvature, after reflection, the ray of light will travel in the same path. That means there is no deviation, there is no change in the path. Whichever direction the incident ray of light is passing, after reflection also the reflected ray will travel in the same path. So that is the first condition we have to remember. Okay, so first point is there, when a ray of light passes from the center of curvature, after reflection, that means the ray of light passing from the center of curvature is the incident ray, and this ray of light falls on the mirror here, that is on the concave mirror, and after reflection it passes on the same line. Whichever direction the ray of light is going, on the same direction the reflected will also pass. So that means there is no change in the path in case of a concave mirror. So first point is there, when the ray of light passes through the center of curvature, after reflection the ray of light passes through the center of curvature without any deviation. Second point is there. Now in case of a convex mirror, the ray of light is appear to travel towards the center of curvature. Here what will happen is that this is not actually the ray of light is not traveling towards the center of curvature, but they appear to travel to the center of curvature. Okay, so and in this case the ray of light, in case of a convex mirror, the ray of light will appear to travel to the center of curvature without any deviation. And the second point is here, when a ray of light is parallel to the principal axis, after reflection it passes to the focus. In case of a concave mirror. So the second point, the ray of light parallel to the principal axis, after reflection passes to the focus. Okay, so here in case of a concave mirror, here this one is a convex mirror, a ray of light parallel to the principal axis, after reflection appear to come to the focus. It seems that the ray of light are not passing to the focus, but the ray of light appears to passes to the focus. Okay, it comes to the focus. Here the ray of light is passing to the focus, but here the ray of light it appears to come to the focus in case of a convex mirror. And the third point is here, when the ray of light passes to the focus, when the ray of light passes to the focus, after reflection it goes parallel to the principal axis. Okay, so 3 points, remember that. First point is that the ray of light passes to the center of curvature, it goes to the center of curvature without any deviation. Second point is here, when the ray of light is parallel to the principal axis, after reflection the ray of light has to pass to the focus. Third point is here, when the ray of light passes to the focus, incident ray of light passes to the focus, after reflection it goes parallel to the principal axis. Okay, and here also in case of convex mirror also, it seems that the ray of light passes to the comes to the focus. And the fourth one is here, when the ray of light is incident at the pole. When the ray of light is incident at the pole, then the ray of light will be reflected back along the same path, okay, along the same side, forming equal angle of incidence and equal angle of reflection. So in case of the ray of light, when it is incident at the pole, when the incident ray of light falls on the pole of the mirror, not on the focus, not on the center of curvature, okay, but the ray of light directly when it falls on the pole of the mirror, after reflection it passes towards the same side, okay, on the same side, forming equal angle of incidence and reflection. In case of convex mirror also same. Okay, in convex mirror also, when the ray of light it falls on the pole of the mirror, after reflection it passes to on the same side, okay, in which the angle of incidence and angle of reflection will be same. So when you draw the ray diagram, the 4 things you have to remember that. What are the 4 things? Is very simple to understand. Is number 1 is when the ray of light passes to the center of curvature, after reflection it passes to the center of curvature. There is no any change in the path of light. Second point, when the ray of light is parallel to the principal axis, after reflection it passes to the focus. When the ray of light is parallel to the principal axis, after reflection it has to pass to the focus. Okay, and third point is here, when the ray of light passes to the focus, after reflection it goes parallel to the principal axis. Fourth one is here, when the incident ray of light will fall on the pole of the mirror, after reflection it will be reflected back along the same side, forming equal angle of incidence and reflection. So these 4 things you have to remember when you draw the ray